Hey you!
You talking to me?
Yes! Who else am I talking to? Do you want to know how Voltaic cell works?
Nah, no thanks.
Well, too bad! I don't care what you say, because I'm going to be presenting you a stop motion video about it.
Stop motion? Why is that?
Shh! The video is about to start, okay? Here we have a beaker of zinc sulfate and a beaker of copper sulfate. We will attach a wire with a voltmeter from the zinc to the copper. The zinc has a weaker pull of electrons, so it's considered an anode. The copper has a stronger pull of electrons, so it's considered a cathode. The rule is that the electrons always flow from the anode to the cathode. But when the zinc loses electrons, some of the zinc dissolves into the solution, and when the copper gains electrons, the dissolved copper becomes solid. So since more zinc is being dissolved, the mass of the zinc decreases, and since more copper is becoming solid, the mass of the copper increases. Also, since zinc is losing electrons, it is becoming oxidized, and since the copper is gaining electrons, it is becoming reduced. So the concentration of zinc ions increases and the concentration of copper ions decreases. This means that the positive charge builds up in the zinc sulfate and the negative charge builds up in the copper sulfate. In order to balance the charges, we need a salt bridge. This salt bridge is filled with sodium ions and chloride ions. At the end of the bridge, there are cotton plugs which help source the ions into the beakers. The negative chloride ions goes into the zinc sulfate to balance out the positive charge, and the positive sodium ions goes into the copper sulfate to balance out the negative charge.
Wow, thank you. I think with this information I could get 100 on my chemistry project.